Okay, the next thing we're going to do is take a look at some more practice problems that involve section 10.3 from our book. And these will help us out with properties 3 and 4. Now, what we need to know about properties properties 4 and 5. What we need to know about from properties 4 and 5 is that what we have here is a line of tangency, and this is our point of tangent. And what happens there is this is a line that is touching just one point on the circle. And when a radius, which comes from center, connects to that line of tangency, we've created a right angle, and that'll always be 90 degrees. Okay? Now, the first question says, what measure of angle BDC, which is that angle that we just looked at, and what property did we use? Well, that would be property 4, and it is 90 degrees because of property number 4. The second question, what is the measure of the central angle, DCE, which is this angle right here, and what property have you used? Well, we have to back up a little bit to figure out what that is, and what we need to do is indicate how big is that angle. And if we understand that a triangle, all the degrees add up to 180 degrees, we know that we've used up 50 here, 90 here, so that's 140. That leaves us 40 degrees for this angle right here. And because we have a diameter, which is a straight line, and all straight lines are 180 degrees, we know that this angle that is 40 and the central angle, which we're trying to find, this angle here, must add up to 180. So then we know that this angle is 140 degrees. And we use the rule of basically the sum of angles must add up to 180 to figure out what that rule, to figure out the length of that angle. And you can see that there it is there at 140 degrees. Now the next question is asking us what type of triangle in this, and we'll give you a little bit of information here. And if we just change colors and we look at this radius and this radius of that triangle that we're referring to, we know that they're equal. Two radiuses within the same circle have to be the same distance, so that yellow triangle has two legs that are the same. And if we have two legs that are the same, we call that an isosceles triangle. An equilateral triangle is when all three legs are equal, and in this case it's an isosceles because two of the legs are equal. Now to figure out, it doesn't ask this question, but just to go a little step further, to figure out the size of that angle and this angle, that is possible as well. We know that those three angles within that triangle must add up to 180, and those angles are 20 degrees. And we know they're 20 degrees because these two radiuses are the same length, this angle and this angle have to be the same length as well. And we only had 40 degrees left to share between the two angles, so we split those 40 degrees in half, and those two angles remaining must be identical and must be 20 degrees. I hope you found that helpful, and that should help us out with some of the problems that we do in the future involving property 4 and 5. Thank you.